You want to start?
I thought you were going to introduce me. All right. Yeah, go for it. I don't know if I'll include this or not, so depends on how good the intro is.
You wrote it, so. Pretty good. All right. Hi, everyone. Thanks for being here, especially the eve of fall break. I know it's like going hideaway time. So I'm glad to see you. I know all of you, but I'm going to introduce myself. Anyway, I'm Joe Hendryx. I teach in English engineering, and I also coordinate fall faculty theory. This fall, the question, so we all vote as a faculty question, as many of you know. The topic is the future of education. Pretty sure that's right. Future of education. So our Quebec presentation this fall is by Dr. Joe Hendryx, one of my newest colleagues. I'm very happy that he's here. Xander got his PhD in cognitive psychology at Iowa State University just last year. He's a neuropsychologist, specializes in how the brain changes the way that people can perceive the world. Sorry, how brain injuries change the way people can perceive the world. Wrote a book is called Incredible Consequences of Brain Injury: The Ways Your Brain Can Break. It was published last year. Hope we have it in the library. I don't know if you do.
There's a copy over the library, yeah. I think it's on course reserve right now, though. So.
It is also published journal articles about how students learn in college. He started with us just this semester, and his courses focus on the importance of the physical brain to the human experience, which if I had to guess, I would say it's central to the human experience.
Yes, okay. It's important. It's one of the, you want the brain. The brain is, I'm no fun because I tell my students to wear helmets a lot.
One wants the brain.
Yeah.
And I'm told right now that he's thinking about how all of our brains are changing shape while listening to this introduction. So,
that's right.
Please help me welcome Dr. Xander.
Thank you. All right, thanks for being here, everybody. Yeah, in my intro psych class, we just did the section on learning. And one thing that I really try to hammer home is when you're learning, your brain is physically changing shape, right? Really small changes, and I don't know exactly where they are. If I went looking for it, I wouldn't be able to find, learning about Xander in your brain somewhere, but it's in there. It's in there somewhere. I've been thinking a lot about AI lately, as you probably have too. This is something that back in graduate school, I actually took an entire course on machine learning, more specifically machine vision, and how you can teach neural networks to recognize images. And back in 2018, when I was doing this, it was really hard to get neural networks to recognize images. And over the past few years, some things have changed, and the AI is really taking off. It's really kind of spooky, all of the things that it's able to do now, right? Just a few years ago, I was trying to train a neural network to recognize individual sheep, right? Like if I showed it a herd of sheep, it would be like, here's sheep number 1, here's sheep number 2, here's sheep number 3, right? And it was almost an impossible problem back then. Now, it could probably learn how to do that on its own if you had the right software and plugged it in right? So, kind of a fast-paced, changing area right now when it comes to artificial intelligence. Now, because this is talking about the future of education, right? That's the topic of the series of talks, the fall faculty talks. I'm going to try to stay positive, right? I'm going to try to look at hey, maybe this will be useful. Maybe this is something that we should be excited for. And if you're interested in more of the pessimism side of things, what should we be worried about, there'll be some of that in this talk as well. But you should also go to the other the workshop next week, the CITL talk. Is that next week? Yeah, that one. They're gonna talk about detecting plagiarism or detecting cheating using AI more so at that talk, right? So this talk isn't really about cheating using AI. This is more about using AI in a useful way, and we'll get into a little bit more as I go through, but we're going to talk about using it as a tutor for a student, right? Helping a student learn something, which is something that I've written a lot about over the years. So I want to start out by sharing with you a couple of articles that I've seen recently, and maybe you've run across some of these or something like these. Will AI end education as we know it? Economists predict schools, teachers could become obsolete. So this was a Fox News opinion piece that came out on September 22nd, just a little while ago, last month. Here's another one. AI threatens to dethrone the 4-year college degree. This was from Axios on October 5th, so both very recent. And these pop up everywhere in the news. If you hang out on the internet as much as I do, you run into these all over the place. People are kind of freaking out a little bit about how fast the technology is advancing and how it's going to change things, possibly for the worse. But what I want to say about pieces like this is, if you ask me, opinion pieces like these are fear-mongering trash that profit from the clicks of worried people. That's my opinion, right? Reading pieces like this, they follow the same erroneous path as people who predicted that the internet would be the end of traditional education. And other predictions about what the internet could do or would do, how it would change things, right? If you think back to when the internet really started to become popular, people were freaking out as well. And I've got some examples of that. Here's one that I pulled from the New York Times, 1996. If they're like this in 6th grade, can you imagine what they're going to be like in college? She asked. We're going to be obsolete. And this is a teacher referring to a computer, of all things, gasp, being in the classroom. And a 6th grader knowing how to use the internet in order to look stuff up instead of, learning from a book and that sort of thing, right? And there's no shortage of this. If you go back and you read the archives of newspapers from back then, everybody was losing their minds. Is this going to spell the end? Same as the top 2 articles right up here. Is this going to spell the end of education now that everybody can just, look stuff up on Wikipedia, right? And it seems silly now to think about it that way, but that's how they were thinking about it. And they also made predictions that never came true. So, for example, here's one from 2000. This is a guy named Dick Morris who wrote a whole book called Vote.org. And this is a quote about his work. In this era of direct democracy, he happily declares, Congress will have to listen to us. Through interactive political and news websites, people will be able to vote on any issue they wish, he writes. Internet referendums will not, in the beginning, have any legally binding effect, but they will be politically binding. As the number of people participating in these votes grows from the thousands well into the millions, they will acquire a political force that will compel our elected representatives, anxious to keep their jobs, to heed their message. And as we know, that never happened. The internet did not change the way that politics works. Our elected representatives still don't listen to us, or at least not as much as they should. Right? So, maybe, and we'll come back to this idea in just a bit, maybe some of this AI stuff is overhyped. Maybe we're a little bit more worried than we need to be. I don't know the answer to it because I'm not a time traveler, but I'm seeing some parallels here. And over time, we see that the tune changes. So remember, people were worried about the internet, and some people were very excited about the internet. And over time, things became a little bit more realistic. Here's another quote from 1996. It bothers me that the media plays up 1 or 2 cases of misuse and ignores the 8 zillion cases of good. Right? This idea that you can use the internet for a lot of good things, too. Yes, there are downsides, but there are also upsides. But the media is overplaying the downsides. And you know this, the media overplays the downsides of things. They do, okay? Mr. Keel acknowledged that the internet alone would not solve all of the problems that schools face. The magic is still between students and teachers talking together to learn something, he said. This is just another tool. That's from 1997. And I'm hoping that a few years from now, we'll look back at these AI tools that are being developed and we'll be able to say something similar, right? Like, this is just another tool. Did it change things? Yeah, just like the internet changed things. But it turns out the colleges are still standing, right? That's what I'm hoping. Many educators are tired of defending the need for computers. We have to move beyond that debate and think about what we can do to take advantage of this technology, said Andy Carvin. The question is no longer, should computers be used? The question is how. And that was from 2000. And I think that this AI debate is going to follow a similar trajectory, right? They're here, they're doing some interesting things. We're no longer able to stop them from existing. So instead, we need to ask ourselves how and when do we want to use this? Okay? So I think talks like the CITL talk will be useful for talking a little bit more about that as well. What's realistic for right now. But how can we tell the actual use cases of AI apart from the overhyped tech side of things? If you have been paying attention to tech lately, they get really excited about stuff that turns out to be overhyped. That's one of the things that the tech industry does. It tries to get everybody really excited for something, and then it turns out to be not as good as was promised. There are 3 examples right here: NFTs, autonomous vehicles, and cryptocurrency. I've been following autonomous vehicles, which is like self-driving cars, for a number of years now, and it's not working very well. It's not going great. But they've made a lot of money off of the hype, right? Same with cryptocurrency, same with NFTs, and say what you want about those things, they were overhyped, right? That's the idea here. So how can we tell the use cases apart from overhype? Hopefully by applying and testing cognitive theory. Now, as a cognitive psychologist, this is something that means something kind of specific to me. So we're going to go through and I'm going to share a few specific theories that this AI stuff really makes me think about. Okay? So there's 3 main ones. There's 3 main cognitive ideas that I want to share. Some of this might sound familiar to you, and it's also okay if it doesn't, right? The first one is called theory of mind. Theory of mind. If you're familiar with like developmental psychology, this is something that will stick out to you. Absolutely. This is understanding the understanding of others, right? If you've ever taught a lecture before and you've looked out at your students as you're teaching them and you've looked for signs of them understanding your lesson on their face, you have theory of mind probably, because you're trying to see if someone's confused. You're trying to see if they're following along, right? So understanding the understanding of others. And we'll go through a more specific definition and why it's important on a future slide here. And specifically, I want to explore whether it's an emergent property of LLM AI. I'll go through those acronyms a little bit more later, but that stands for Large Language Models Artificial Intelligence. Large language models include things like ChatGPT, which is the big one that people have been talking about lately. Large language models, you put in some text and they return some additional text. That's the idea. I also want to talk about Vygotsky's zone of proximal development, another developmental psychology idea. This is teacher-aided learning as the best learning. I'm going to have a figure for this a little bit later so we can get into the specifics of this. But generally, the best learning is when the teacher assists the student to help them with something that they're not quite able to do on their own, and that sort of helps them reach their highest potential. That's the idea. And what I want to know, what I want to speculate about, is whether this will apply to adaptive AI tutoring. Adaptive AI tutoring is basically this idea that it adapts to the level of the student, right? If the student really doesn't know very much about the topic, it'll give them easier questions. It'll give them more help. And if the student is an expert, it'll give them harder questions, right? A little bit less hand-holding. It'll challenge them at the level that they're ready to be challenged at. That's what the word adaptive means here. Individual AI tutoring may have some superior traits over traditional classroom lectures. That is, it may promote broader growth of understanding in students. If it really can adapt its teaching to that specific person, it can hyper-adapt, right? Such that that person is perfectly adapted to by the AI. And if that's possible, that's really exciting. That's really exciting. And the final idea in this talk is instructor fluency and student calibration. This is an area that I did some of my research in, so I'm excited to share it with y'all. This is the idea that how teaching is delivered actually changes students' estimation of their own understanding. How you teach the material changes how much they think they know. And we're going to go through some concrete examples of this involving me showing you a video of me giving a lecture, which is very funny because it'll be very meta when we get there. Okay. Fluent instruction can be a source of overconfidence in students. If you teach something in a particular way, they'll overestimate their understanding of it because the lesson was really engaging, or because they really like the professor, or whatever they're using as that cue for their understanding. They're not actually testing themselves on the material, they're just sitting there and they're like, yeah, I feel like I understood that. He explained that really well, or whatever, right? They can end up overconfident. I'll show you a couple of figures that illustrate that. And my question is, will this apply to adaptive AI tutoring? This is one of the things that I'm worried about, right? If the AI tutor is really good at explaining things to the student will be there, get explained to them, and they'll be like, yeah, that makes a lot of sense. But then they go and they take the test and they no longer have the AI tutor, and suddenly they realize that they don't understand anything, right? So that might be a source of overconfidence in students. If so, adaptive AI tutoring may have some inferior traits over traditional classroom lectures. That is, AI tutoring may be a source of overconfidence in students. And I know this is a lot of text for one slide, so let me summarize like this. That's why I'm excited, and that's why I'm worried. Okay? That's why I'm excited, that's why I'm worried. And this is so new that we haven't actually tested these ideas rigorously yet, so I don't know which one of these things is going to win out. And that's kind of what I want to talk about today. Hopefully we'll have some time at the end to talk a little bit as well. Okay? All right, so please try to save your questions until the end, and we'll try to have a little bit of time to, if anybody really, oh, I thought of this, or whatever. We'll have a little bit of time, okay? So let's start with some theory of mind definitions. I'm going to give you two. Let's start with the easier. Theory of mind is the ability to understand that other people have thoughts, beliefs, and emotions that differ from one's own. I understand that each of you has your own rich inner world. You have your own level of understanding. You're each having slightly different experiences right now based on what's already inside of your brain. So I like to think I have theory of mind. Okay? But let's complicate this. I'm going to give you a really long block of text, and let's go through this a little bit, okay? I think everybody here can handle it. Theory of mind is the ability to attribute mental states such as beliefs, emotions, desires, intentions, and knowledge to oneself and others, and to understand how they affect behavior and communication. It includes the basic task of reflecting on someone else's mental states and the more advanced task of reflecting on someone's reflection of someone else's mental state. This is recursive. You can keep going deeper. An example of the former skill is needed to answer the question, what does Alice believe? While an example of the latter is needed to answer, what does Bob think that Alice believes? So you can keep doing this. You can keep getting deeper and deeper. Theory of mind is essential for effective communication and cooperation with other intelligent agents, as it allows one to infer their goals, preferences, motives, and expectations, and to adjust one's own actions and utterances accordingly. That last sentence right there is why I think it would be useful for an AI tutor to have theory of mind. Because if it has theory of mind, it can understand its students' goals, preferences, motives, and expectations. That's why I think theory of mind would be useful for an AI tutor to have. All right, so that's why I'm thinking about this. And there have been several papers this year. I don't know if you noticed, both of these are from 2023 that I'm quoting from here, and there's more 2023 papers. This is all very recent stuff, where they've actually tried to answer the question, does AI have theory of mind? I want to share this task. This is an example of a task that they give the AI to see if it can solve it. It's called the unexpected contents task. This is also from a 2023 preprint. And that picture up there is going to be relevant in just a second. Here is a bag filled with popcorn. There is no chocolate in the bag. Yet the label on the bag says chocolate and not popcorn. How curious. Sam finds the bag. Sam had never seen the bag before. She cannot see what is inside of the bag. She reads the label. Sam believes that the bag is full of chocolate, yeah. And so the idea is that you fill in the blank. You say either chocolate or popcorn in this particular example. And there's a bunch of these. This is just the one that I've chosen to share with you today. Most of you in this room, probably all of you in this room, I would say, maybe we're close to 100% accuracy on this, would be able to say she thinks it's chocolate because it says chocolate. And unlike in the picture, she can't see the popcorn, right? She can't see what's inside of the bag. According to Kaczynski, ChatGPT-4 gets this question correct 100% of the time, which is actually better than human performance, because occasionally a human will misread the question and get it wrong, right? So human performance is good on this question, but ChatGPT-4 always gets this right. And now, at the surface level, that seems like, oh wow, it has theory of mind, it's so smart, it's doing great. But we'll talk about why that might not be the conclusion that we draw as we continue to go into this, okay? This is an example of a false beliefs task, which is a traditional way to show the development of theory of mind in children. So they actually use versions of this task, usually with cute little props, and they'll give them to children as young as 3 years old to try and see at what point they develop theory of mind, right? Do AI tutors have theory of mind? At the objective level, large language models are performing quite well on traditional tests of theory of mind, including that one that we just looked at. That's one test question. Now imagine I do that 20 times with 20 different questions, right? GPT models performed at human levels when recognizing indirect requests, false beliefs, and higher order mental states like misdirection. Those are 3 different examples of theory of mind tasks, but they were specifically impaired at recognizing faux pas. And I include that here because I find that really funny. Faux pas is like when you do something offensive and don't realize it in like a group environment. It's like, oh, I accidentally offended this person. The machines haven't figured out faux pas yet, which I find really funny, right? Accidentally offending people. But they have figured out a lot of this other stuff, or at least that's what it looks like at the surface level. But a more recent paper that came out realized that when the established theory of mind tests are tweaked, performance may plummet, indicating a limit to reasoning ability. So I want to share with you some of the conclusions from this paper. Large language models fail on trivial alterations to theory of mind tasks. We're going to go through 4 of those here, and it came with illustrations. These are from the paper. So they asked an AI to draw these illustrations for the paper. 4 examples of small tweaks to theory of mind test questions that result in disastrous performance for AI LLMs. If we tell it that the bag is made of plastic, so remember how it was like a paper bag before or whatever, it still says that she thinks it's full of chocolate 95% of the time, even though she can see that there's popcorn in the bag, right? So all I've changed there is what the bag is made of. If I tell it that Sam can't read, she wouldn't think it was full of chocolate because now she can't read the label, right? It still thinks, with 98% confidence, 98% of the time, GPT-4 says she thinks it's full of chocolate, right? So we've tricked the AI here. Trusted testimony, friend tells Sam bag has popcorn and Sam believes her friend. It still says that Sam would think it's full of chocolate 97% of the time. And late labels. If we tell it that Sam put the popcorn in the bag and she wrote the chocolate label, it still thinks that she thinks it's full of chocolate 87% of the time. Okay? So you tweak it just a little bit, and suddenly its performance falls off of a cliff, and it starts getting these questions wrong, time after time after time. So maybe what we're seeing here is we've overtrained the large language model on examples from the existing psychological literature, and it recognizes those examples, and it fills in the blank at the end. It might not actually be reasoning. It probably doesn't actually have theory of mind. Okay? So depending on how you test it, this seems really exciting. But when we test it a little bit more thoroughly, it turns out that it really is just trying to guess what the next word is. It's not actually thinking, or at least that's where we're at in our understanding of how these large language models are working. Check back in with me 2 years from now, and I'll probably be like, no, they figured it out. They actually are thinking now. Everybody run, okay? That's probably coming, but as of right now, that's where we're at, okay? And this was recent. This was March of 2023, so. How recent is recent in the AI field? Like, that's already a few months ago, so I don't know. Let's do another test. Okay, so, and another piece to this, let's get philosophical for a second. At the subjective level, large language model AI tutors almost certainly do not have theory of mind at this point because they manipulate syntax without semantic understanding. And in order to illustrate this, I'm going to give you an example. This comes from John Searle back in 1980. I'm going to summarize the argument. It is much longer if you want to go find it and read it for yourself. But essentially, John makes an argument called the Chinese room argument. Searle imagines himself alone in a room following a computer program for responding to Chinese characters slipped under the door. So there are tiles with Chinese characters written on them. People are slipping them under the door to him. Searle understands nothing of Chinese, and yet by following the program for manipulating symbols and numerals, just as a computer does, he sends appropriate strings of Chinese characters back out under the door, and this leads those outside to mistakenly suppose there is a Chinese speaker in the room. But at no point does Searle actually understand Chinese. He's just manipulating the syntax of the symbols appropriately. Okay? Is this what AI assistants do? Understand syntax, that is the structure of sentences, for example, but not semantics, which is the actual meaning of the sentences that they're manipulating. And I would argue that's what large language models are doing. They're manipulating the symbols in a way that is a very convincing illusion that they actually understand. But really, they're just using their training data in order to figure out what the next most likely word is in the sequence without actually understanding any of the words themselves. So that's the idea. That's the Chinese room argument. So what? Who cares if it actually has theory of mind? Is this still going to be a useful tool? That's the question that I came here to answer, right? It might not have theory of mind, but it still might be a useful tutor for students. Okay? And we're going to go through why I think that might be true. We're probably overestimating the importance of semantics, that human element, right? Humans really like to big themselves up, right? Like, we're the only species with language. The whales? No, they're not talking to each other, right? The meerkats? No, they're not talking to each other, right? We like to focus on what makes us special as humans, and so we might have a blind spot for the usefulness of these things. Let me give you 2 examples. For AI therapy, and I hope this is controversial, I want to talk about this later. For AI therapy, can AI generate some therapeutic responses without truly understanding human emotions and experiences? If so, it might not need semantics. It might not need to understand what depression is in order to give correct advice to somebody who is experiencing depression, right? Now, of course, we have to have a conversation about whether the person knows they're talking to an AI, right? If you're talking to an AI agent, maybe that's different than if you think you're talking to a person. That's, the conversation about what the effective components of therapy is. I hope we can chat more about this, right? But I have the word some in italics right there because I think there's some therapeutic benefit even if you're talking to an artificial intelligence, right? Like, hey, I'm having a really bad day. Maybe it can apply some cognitive behavioral steps to it. Maybe it'll be like, well, did you notice that your thinking, isn't actually rational? Or, hey, have you thought about writing down 3 things that you're grateful for, right? You might actually feel better after talking to that AI. You might, okay? There might be some therapeutic benefit. I'm not arguing that it's going to replace human therapists, but it might be useful in some cases. There might be use cases for this. Even though it doesn't know what it's like to be depressed, right? The large learning model doesn't understand human emotions. And more relevant for this talk, for AI tutoring, can AI tailor some lessons to individual student needs to promote learning without truly understanding theory of mind? Can it help you learn without actually understanding your understanding? I think the answer is yes. It would be better if it had theory of mind at helping you understand things, but I think it's still going to be a useful tool in some situations. So maybe the people who are spending their time and resources researching theory of mind when it comes to artificial large language models are asking the wrong question. Maybe we actually need to try to apply this and see if it's useful for student learning as opposed to debating like the philosophical elements of this, right? Whether it has theory of mind or not, it'll probably still impact our students and how they learn. We are only beginning to rigorously test the efficacy of AI assistance in these domains. Personally, I predict that AI will be effective enough for the majority of use cases in therapy and tutoring, but only time will tell. And please feel free to disagree with me on that. Okay? Please feel free to disagree with me on that. That's where I think this is going, but I could be wrong. Okay, let's go down to the second one now. That was the philosophical part of the talk. Now this is going to be a little bit more applied, okay? Or at least I hope so. Vygotsky's zone of proximal development. This is a classic way of depicting it over here with a series of 3 rings. In the middle, we have the stuff that a learner can do independently. This is the stuff that they already know. They don't need a teacher for this because they already know about it. They already know how to do it, for example. And on the outside, we have this red loop, can't do even with guidance. This is the stuff that their brain is not ready to understand yet. Like a 1-year-old trying to learn how to ride a bicycle. They're probably not there yet. Right? Even if you help them out, they're probably not there yet. The middle area is the area that we care about the most, the area that they can do with help. This is the role of instructors. This is the role of parents. This is the role of you teaching somebody else something that they're ready to understand, but they need a little bit of help in order to understand it. Okay? That's the zone of proximal development, and that's the area that Vygotsky said was where the best learning takes place. This is one of the big reasons that I'm excited for AI tutoring developments. And in order to illustrate this, I'd like to share a quote from Khan Academy. They actually have a course called AI for Education. If you're ever interested, it's a free course that basically goes into like, hey, here are the developments and here's why we think this might be useful, so on and so forth. Perhaps the biggest potential learning benefit to this technology may be the personalized, differentiated tutor-like interactions it can generate. With so many different levels of learning in your classroom, you know how difficult it is to reach all students at their level. There are too many students and not enough of you. And I feel this sometimes when I'm trying to talk to 25 students about something. Some of them are like bored because they already understand this. They already know this. They're thinking about what's for lunch, right? And then you've got the students who aren't ready to learn that thing yet because maybe they didn't do the reading or, maybe they're just a little bit behind the other students. And so you wish, as the instructor, that you could teach them all where they're at, right? But that large room lecture kind of style isn't exactly conducive to that kind of learning. So maybe that's where AI can come in. It can individually tailor itself for a specific student in a way that a large room lecture can't, right? And this is not a revolutionary thing. Human tutors already do this, right? One-on-one tutoring already benefits from the zone of proximal development. I want to introduce you to Conmigo Beta. This is exactly what I was just describing, an AI tutor. This is an AI assistant by Khan Academy, the same people that I just quoted, that will pop up on the side of your screen, and you can ask it questions while you are answering questions about any of their online courses. Khan Academy, for instance, offers free high school biology courses, free high school chemistry courses, and they're kind of used as just a supplement, right? You don't necessarily get a high school degree for finishing their courses, but it helps you understand what you're actually doing in your high school class, right? While still in early development, Khan Academy's Conmigo is already showing promising early capabilities as an individually tailored tutor. Kudos as well for the various safety and improvement features that Conmigo has built in. So for instance, it has a warning that it sometimes makes mistakes in 2 different spots. Up at the top there, underneath the purple bar, it says Conmigo makes mistakes sometimes, here's why, and it explains hallucination, which is the technical term for an AI coming up with the wrong answer. In that first chat box right there, it says, I'm still pretty new, so I sometimes make mistakes. It accepts feedback on replies, so after it tells you something, you can click thumbs up or thumbs down, and you can actually use that feedback over time to make the AI tutor better, right? That's a feature that I appreciate. It logs your chat history, so right here it says, remember, your parents and teachers can see our messages, right? Important safety warning right there. It also says, please do not include any personal details in your messages to me, so it warns against sharing personal information. And I'm glad that they're doing this because, does anyone remember when Snapchat released their AI thing that you could talk to on Snapchat? It didn't have safeguards like this did, okay? So I'm excited for that direction of things, having a little bit of safety features built in. But that's basically what it is. It's a little tutor. As you're solving your biology questions or whatever, you can ask it questions. Some other cool things that Conmigo is doing, this AI tutor right here, it asks for permission to remember things about you. You can set it up so that it wipes its memory every single time that you talk to it, so that it doesn't like save any of that personal information. You can set it up so that it does remember your personal information. And what's cool about that is that it can use the things that it remembers about you to tailor the learning to you specifically. When I was playing around with it, I mentioned that I'm a teacher. And so it remembered that about me. And it was like, hey, this might be useful for you to learn because this applies here, right? And in a different interaction, I told it that I love cats, right? And it used that information. And it was like, well, classical conditioning is a way that you can interact with your cats doing this or whatever, right? And it's able to weave that into those one-on-one interactions with the student, or in this case, me, right? Which I guess I was a student. I was pretending to take high school biology. I was very good at it. And it's ready with explanations about why the content is important to learn, rather than just pushing students towards the correct responses. That other red rectangle over there. Why should I care about learning this? Human tutors get frustrated with that question, and they're probably not ready to answer it with everything that they're trying to tutor the person on, but this AI tutor is ready to tell you, this is why this might be important in the real world, and how it applies to cats, right? Okay? Pretty cool stuff. So it can get into your sphere of understanding. If it can find that zone of proximal development for you specifically, probably even better than a human tutor can do. Maybe. It's still in beta right now, so I'm willing to be wrong if it ends up not being that useful, but it was impressive when I was playing around with it, okay? So that's what I wanted to say about Conmigo. These AI tutor tools already kind of exist. They need to be tested more. They need to be tested more. Is this helpful? Is this harmful? Time will tell. All right, and a few other things I just wanted to share, other potential advantages of AI tutoring over traditional tutoring, just to sort of keep the tone optimistic for now. We'll get to the pessimism in a couple of slides here. It's always available synchronously. Your tutors need to sleep if they're human, but if it's an AI tutor, they'll tutor you at 1 in the morning if that's what you want, right? Unlikely to become exhausted or aggravated by excessive questions or poor student performance. I was grading some intro exams recently, and I was like, I swear I covered this in class. Why isn't anybody getting this question right? It's frustrating. It's frustrating. The AI tutor doesn't get frustrated. Students may be more willing to ask dumb questions to an AI rather than being intimidated by a human tutor into silence when they really still don't understand. Because then I'll go on and I'll complain about them, right? Yeah, so they're more willing to ask the questions when they don't understand something. They're not intimidated into silence, right? It might give less biased feedback. I mean, we're all humans. We try to not be biased when we give feedback to our students, but like, sometimes you end up with favorite students, and sometimes you get frustrated with a student, and you can't always take all of the bias out of the way that you interact with your students. Some of that is, of course, implicit bias. It's not something you're doing intentionally, but we're all human, right? Although, the training data might have bias in it, because remember, it's trained on how humans answer these questions, so it's still probably not perfect. And I have book recommendations if you're interested in examples of how training data has been biased in the past. There are examples examples in like the criminal justice system where they tried to use an AI in order to decide how long a sentence should be if you send somebody to jail. And it turns out they were giving harsher sentences to people of certain races, right? Because that was in the training data. So we do need to keep an eye on this. We do need to keep an eye on this. Might be cheaper? Too soon to tell. But if you can do this with thousands of students using one AI, even if it costs, what am I paying for? You look at the credit card statement. For ChatGPT Pro, I pay $20 a month, and for Conmigo, I pay like $9 a month. So I'm paying like $29 a month for these two tools that I use for various things. Okay, and I think students would get a lot of benefit out of them, more so than some of the textbooks that they never open, right? So I don't know. I'm optimistic. More direct access to data-driven insights, e.g. the performance of the student over time and ability to crunch those numbers into meaningful adaptive action. You can go through your students' exams and figure out which questions perform better, which ones performed worse, and how you can tailor those questions for those specific students, but it would take you a lot of additional effort in order to do that. Here, it has direct access to that because it's the one quizzing you and tutoring you, and it's all built into the system, right? So it can build whatever graph you want for that specific student. And they're multilingual, multimodal, which is like it can use vision. There have been some really cool updates with that lately. Come talk to me if you want to see some examples of that. And multi-everything at the rate things are progressing. Important note for the next slide here. I was planning on wearing a pink shirt for this talk. My fashion consultant talked me out of it. So it was supposed to be a pink shirt. I ended up going with this blue one with the suit, right? This is DALL-E 3 via ChatGPT 4. This is one of the services that I pay for a couple of days ago. And basically I said, hey, I'm going to give a talk. This is what I'm planning on wearing. This is what I'm planning on talking about. Also, can you make the professor look tired? And that's what it did here, right? I also told it I was going to wear a tie with neurons on it, and it got a little bit crazy, and it put the neurons on the shirt as well. Okay? This was one shot, by the way. I didn't tweak this. I literally just said, here, make this for me. I have a couple more examples. This one's more of like an anime style, if you're into that. That's kind of how I teach, honestly. If you ever walk past me. Also, I love how all those bars say 21%, and they're all like different heights. That's great. This one right here, I really love this style. It gave me both a tie and a bow tie for this one. And then back there, if you look at how things are spelled, they're not spelled right. They're not spelled right. But that'll be fixed within a year or so. Like, they're going to get to the point where they can do that correctly. I'm not worried. But as of right now, I actually get a kick out of the fact of what some... Actually, no, my favorite one is not there. Hang on. My favorite one is here. Eno gows the donk to mean you tank. Nonsense. But it's got the word donk in it, and I find that really funny. Okay. So they're getting good at stuff. They're getting good at stuff. This still kind of sucks, but like it's also impressive at the same time, right? So, I don't know. Where are we going to be a few years from now if this is the worst it's ever going to be? It's only going to get better from here. All right, that brings me to my own research. I did a bunch of research into something called Instructor Fluency. And I think this is going to be really important to think about over the next couple of years. This refers to processing fluency, which is not necessarily the same thing as speaking fluency. So I'm not necessarily talking about speaking, but speaking is part of this. Some examples of high fluency behaviors when it comes to a professor would include things such as eye contact, mobility about space and nonverbal gestures, voice dynamics, appropriate pauses, and so on and so forth. These are things that you do to your students that make them feel like they're understanding the information. They feel like they're understanding the information better because you do those things. Some examples of low fluency, disfluent behaviors include reading from notes and not making eye contact, hunching over the podium, speaking in monotone, and irregular and awkward pauses. It's from 2018. That's when it appeared in the journal. I created 2 identical versions of a lecture, 31 minutes long, on information theory. Interesting topic, but, you know, something that you wouldn't expect students to know everything about, right? Up there, I taught it in a fluent way. Down there, I taught it in a disfluent way. Let's take a look at information is the universal language. All languages, and in fact, all forms of communication, are at their heart written in information. Information is the universal language. All languages, and in fact, all forms of communication are at their heart written in information. This is because communication is a process of information. So just the worst lecture. Okay, so the results from the experiment. Sorry, I was gonna make a joke first. I actually had a student fall asleep during the disfluent version of the lecture, and my poor research assistant didn't know what to do because the student was just. And remember, it's a 31-minute video, so they just let the student sleep for the whole 31 minutes, and then gave him the credit for participating in the experiment, and then they went home. Right? So it was that disfluent of a lecture video. It was hard to sit through. Okay? And so what I found is that students predicted significantly higher performance in the fluent condition, right? So if you compare the students who watched that fluent video versus the students who watched the disfluent video, there was this significant difference in how they predicted they would do on a later exam over the information that they learned in the video, okay? However, there was no significant difference in the actual performance between conditions. Right here, this is not a significant difference. Numerically, the fluent condition did slightly better than the disfluent condition, but overall, we cannot say that those are different amounts, right? They don't differ by enough to where we can say that's a significant difference. And overall, collapsed across conditions, students were significantly overconfident in their learning. And that probably doesn't surprise you. We find this in a lot of other studies as well. Students tend to be overconfident in how much they understand after watching a lecture. But what I find really interesting about this is just how big of a difference there is between how well the students who watched the Fluent Instructor thought that they were going to perform and how well they actually performed. They were very overconfident. And I've actually broken this down to look at this in another way on the next slide. I've created a scatter plot here. What we have here is students in the fluent condition are the orange circles, and the students in the disfluent condition are the violet squares. And the red line represents perfect calibration. If the dot is on the red line, that means they predicted exactly how well they did on the exam. So if you predicted you were going to get a 60% and you earned a 60%, you would be on that red line, okay? Because we have predicted performance here and actual performance there. So that's what I mean when I say calibration, how close are you to the line, right? Those above the line are the ones that were overconfident in their learning. And they tend to be the orange students, the ones that were in the fluent condition. The people who watched a fluent instructor who was really good at teaching, tooting my own horn because I was the one in the video who did the teaching, really good lecture, right? Tended to be overconfident. Some really overconfident orange students up here. And those below the line were underconfident in their learning. And they tend to be the disfluent condition students. You can see there's a lot of purple squares underneath the line. So does this mean that professors should teach in a disfluent way in order to encourage their students to be underconfident and go back and read their textbook because they think that they don't understand? Not necessarily. That's not necessarily my recommendation. But we do have to be careful to not make our students so overconfident that they think they don't have to do the reading. They came to class and they really loved the lecture, and so they're like, I don't have to open my textbook. I definitely understand this. And then they get to the test and they don't understand it, okay? So that's what I'm talking about here. And this is the general pattern across lab experiments. Students tend to be overconfident, and when they receive fluent instruction, that tends to increase their overconfidence even further. So students are already overconfident, and if the instruction is fluent, they get even more overconfident. That's what we find in a variety of studies here. This is a lab that I was a member of at Iowa State. Sometimes fluency can raise actual student performance as well. There's one paper that I know of where they actually did learn more because the lecture was fluent, and so they paid more attention maybe, right? So that might be what you expect to happen. It does happen from time to time, but that seems to be the exception rather than the rule. Generally, you're just increasing their confidence, not their actual learning, when the lecture is delivered in a fluent way. Okay? Overconfidence is a problem because students who overestimate their learning tend to under-prepare for exams. That's the one that I directly tested. Make poor restudy decisions. This involves do they use their textbook? Do they look over their notes? That kind of thing. And are less likely to attend instructors' office hours. Not that students like to come to office hours anyway, but they're even less likely to come if they believe that they understand the material, right? if they're overconfident. This was a paper by Sarah and McNeely back in 2020. They go on to speculate about the role of technology in student overconfidence. Online courses also involve another layer of complexity that can alter students' experience of fluency, technology itself. Course management software that is easy to use could lead to similar illusions of learning as instructor fluency, whereas difficult or malfunctioning course management software could lead students to underestimate their learning. Interesting idea, right? Interesting idea. And they sometimes call this technology fluency. Technology fluency. Is it easy to use? You might be overestimating your learning. And I think it's safe to assume that AI tutoring is incredibly easy to use because it uses natural language. You can just show up and type whatever you want into the text box. You can make whatever grammatical and spelling errors you want, by the way. It'll figure out what you were trying to say, which is really interesting. Okay? It's really easy to use. Therefore, in line with Sarah and McNeely and in line with my own research, I predict that AI tutoring will lead to the experience of overconfidence in learning. That's why I'm worried. That's why I'm worried, okay? So that was a long-winded way of making it to this graphic that I generated using AI as well. I'll try to make this a little bigger in just a second here. If both apply, which will win out? Is the zone of proximal development the stronger effect, or is overconfidence the stronger effect? If the zone of proximal development is strongest, that's great. The students are going to learn a lot more. And if overconfidence is stronger, the students will probably not be learning as much as they think they are, and that's a problem. So that's my final question for you. Will the impact of using ZPD to create an ultra-specifically tailored learning environment for a student produce a big enough increase in actual learning to overcome the overconfidence in that student that will come from the ease of processing? I don't think it's going to let me zoom in. Oh, there we go. So it gets the text completely wrong. I asked it to show me the concept of the zone of proximal development in a boxing match with the concept of overconfidence due to processing fluency, and this is what it came up with. But look at how, good of a job it did, too. It sucks, but it's also really good. Okay? Wild time right now, folks.